Hello everyone, today we're going to talk about complex numbers, section 3.4 in our book. So we should have at least covered the idea of imaginary numbers before pre-calculus. So that's all they want. Complex numbers, we're just saying it's going to have a real and it's going to have an imaginary part. So it's going to have that I term to it. So the real term in this complex number is -10, and the imaginary term in this complex number is 7. So the -10 is just our constant in this complex number, and the 7 is, if you want to think about it, the coefficient in front of our imaginary number. Okay? So that's what they mean by real and imaginary parts of a complex number. Complex number just meaning we have an I in there somewhere, an imaginary number in there somewhere. So now we're going to take our complex numbers and add them together. So to add complex numbers, I add the real parts, and then I add the imaginary parts together. So that gives me 3 plus -2, and then -4 plus 7i. So we just add the numbers in front of the I together, add the real numbers together, we end up with 1 plus 3i. And this is written in a plus bi form, where our real number comes first, and then our imaginary number comes second, the one in front of our I. Okay, next complex number. Now they have us multiplying complex numbers together. So we're going to FOIL it, we're going to distribute it the same way we always would, but we're just going to have imaginary parts to our answer. So as I FOIL, I get 6 times 2, 12. 6 times -3, -18i. 2i times 2, positive 4i. And then 2i times a negative 3i gives me a negative 6i squared. Right? That I is squared. So the reason why I put the I squared like that in parentheses instead of just like a typical I squared is because this is very special. I squared turns into a -1. So an imaginary number squared just turns into -1. So that's cool because then that imaginary part will drop out. We'll just be left with these two imaginary parts. So let's simplify a little bit further. 12, and then a -18i, a positive 4i gives me a -14i. And then this was a -6, but the I squared turned into a -1. So whenever our i's are squared, or to the 4th, or to the 6th, they're always going to come out with -1. Well, there'll be -1 and then different multiplicities of -1, and we'll get into other examples of that. But now we can simplify finally. This gives us 12 minus 14, 14i plus 6. So our overall answer in a plus bi form is 18 minus 14i. Now they've got us dividing. Okay, and dividing complex numbers is a little more difficult than just simply multiplying them. So, in order to divide them, I start off by multiplying by the complex conjugate of the bottom. So, if this is 4 minus 2i, I have to multiply by 4 plus 2i over 4 plus 2i. It's kind of like finding a common denominator in a way. Okay, so to divide complex numbers, I multiply by the complex conjugate of the denominator, and then I can go through and multiply straight across, just like I did in the previous example. So if I multiply straight across, I get 44 plus 22i plus 20i plus not 5, 10 I squared. Okay, and then we divide that. 4 times 4, 16. 4 times 2i plus 8i. Negative 2i times 4 minus 8i. And then negative 2i times a positive 2i is a negative 4i squared. So now we can simplify a little bit. We've got 44 on the top. We can combine our I terms to get a positive 42i. And then remember that I squared turns into a negative 1. So we get plus 10 times negative 1. All divided by, well, we have a positive 8i and a negative 8i, so those cancel. So I'm left with 16 minus 4 times, and this I squared also turns into a negative 1. So as we keep simplifying, we see here we have a negative 10, we have a positive 44, so we end up with a positive 34 plus 42i. And then in the bottom we had a 16 minus 4 times negative 1, so that 4 times negative 1 turns it into a negative 4, so minus a negative 4 makes it a positive 20 in the denominator. I can simplify a little bit further because our numerator has a common factor of 2, giving me 17 plus 21i all over 20, right? Because they both have 2 that go into 34 and 42, so if I divide through by 2 and pull the 2 out in front, I'm left with that. Finally giving me 17 plus 21i, all over 10, because the 2 and the 20 cross out, leaving me with just 10. I don't like how that I looks there. Okay, so my overall answer of dividing those complex numbers gives me this, right? Which is good because now we just have the complex number in the numerator and we have a real number in the denominator. So a whole lot neater. And finally, they want us to find all the solutions of this quadratic and then express it in a plus bi form. So if you look at this quadratic, it will not factor nice and neat. So we need to do the quadratic formula. So if you do not remember, negative b plus or minus the square root of b squared minus 4ac all divided by 2a is our quadratic formula. Definitely going to need to know how to do that. And then let's go and plug it in. So negative b, our b term is a 1, so negative 1 plus or minus the square root of 1 squared minus 4. My a, my leading coefficient, is just a 1, so 4 times 1. And my c, my constant, is also just a 1. And I divide that by 2 times 1, because again, my a is just a 1. So simplify, that gives me negative 1 plus or minus the square root of 1 squared is 1, minus 4 times 1 is just 4, so that gives me a negative 3 under the radical with a 2 in the denominator. Now typically, whenever we got to this point, right, and we saw the negative under the radical, we're like, oh, can't factor, we're done. But since we're talking about complex numbers, we're talking about imaginary numbers, we can continue from here. In fact, we want to continue here, because this will give us the other zeros when we go into the next chapter. So, like when we saw, a fourth degree polynomial that only had 2 real zeros, 2 points crossing the x-axis, well, those other two zeros are just imaginary zeros, and we'll get into that tomorrow. But that is why this is important that we get this complex number here and that we write it in a plus bi form. So now that I've got this here, right, that would leave me with negative 1 plus or negative 1, I want to break it up into plus radical. And then since it's a negative under the radical, I can pull the negative out by pulling an I out. So I get radical 3i, basically just saying that this is an imaginary number, right? It's not, we can't see it on the number line, it's an imaginary number. So by pulling that I out, we're allowed to pull the negative out from under the radical, all divided by 2. And then we also get the term negative 1 minus radical 3i over 2, because we got to take care of the plus and minus version of the quadratic equation. Then they want it in a plus bi form, so I'm going to simplify it even further. I'm going to say, okay, I'm going to break this up into two fractions where I have negative 1/2. Right, I'm allowed to do that. I just took negative 1 divided by 2, radical 3i divided by 2. So I get negative 1/2 plus radical 3i over 2. That is one of my terms in complex in a plus bi form. And then the other term is negative 1 over 2 minus radical 3i over 2. So now it's in a plus bi form, specifically my real term, negative 1/2 in both of these. My imaginary term in the first one is a positive radical 3 over 2, and the imaginary term in my second factor is a negative radical 3 over 2. So eventually we got down to finding these two roots of the quadratic. So the solutions to the quadratic are these two terms. So go ahead and try the examples that accompany this on the PowerPoint, and we'll talk about it in class tomorrow.